From LP Savani Riverside School, Krupali Home. Hello students, in the chapter number 3 in the earlier session we will learn about different reaction of metal with different components. Here today's topic is how do metal react with solution of other metal salts. Activity 3.12, take a clean wire of copper and an iron nail. Put the copper wire in a solution of iron sulfate and the iron nail in a solution of copper sulfate taken in test tube. Clean wire of copper, clean iron nail, iron sulfate solution, copper sulfate solution, and we have to arrange them like this. Record your observation after 20 minutes. In which test tube did you find that a reaction has occurred? On what basis can you say that a reaction has actually taken place? Can you correlate the observation for activities 3.9 and 10 and 11? Write a balanced chemical equation for the reaction that has taken place. Name the type of reaction. What we have to do by performing this activity, observe the points that in which actual reaction is occurred. As you can see here, this is iron nail and solution is of copper sulfate, and this is copper wire and solution is of iron sulfate. And after 20 minutes we have to observe reaction is occur or not. Reactive metals can displace less reactive metals from their compounds in solution or molten form. Highly reactive metal will displace the lower reactive metal. We have seen in the previous section that all materials are not equally reactive. Means different materials have different ability of doing reaction. Some are high reactive, some are lowly reactive. We check the reactivity of various metals with oxygen, water and acids, but all metals do not react with this reagent. So, we were not able to put all the metal sample we had collect in decreasing order of their reactivity. Displacement reaction studied in chapter 1 given better evidence about the reactivity of metal. It means in the displacement reaction, if some metal is displaced by another metal, then it is called the displacement method, where the metal which is displaced is lowly reactive, but which metal is displaced by another metal, then another metal will be highly reactive metal. It is simple and easy. If metal A displaces metal B from its solution, it is more reactive than the B. A will be more reactive than B because it displaces the metal B. Metal A plus solution of B will give you solution of A and metal B. So A will be more reactive in this case. Which metal, copper or iron, is more reactive according to your observation in activity number 3.2? If reaction is occurred in the iron nail test tube, then iron is the highly reactive metal, while reaction is occur in the copper nail test tube, then copper is the highly reactive metal. 3.2.5, the reactivity series. How we can arrange this series and make this list? Let's see. The reactivity series is a list of metal arranged in the order of their decreasing reactivities. After performing displacement experiments, in the activity number 1.9 and 3.12, the following series known as the reactivity or activity series has been developed. This is the reactivity series. Most reactive metal will be upper side and the least reactive metal will be lower side. And this is series in the decreasing mode. It means highly reactive metal will be upper side, lowly reactive lower side, and in the decreasing mode they will comes downside. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. This is the reactivity series you can see here with the sign of elements. How do metals and nonmetals react? In the above activities, you saw the reaction of metal with a number of reagents. Why do metal react in this manner? Let's recall what we learned about the electronic configuration of elements in class 9. We learned that noble gases, which have a completely filled valence shell, show a little chemical reactivity. Noble gases mean satisfied gases who have fulfilled outer shells. Suppose you can take the calcium who have 20 sorry argon who had 80 electron, means 8 electron in the outer shell, and it is fully satisfied, that are less reactive. Noble gases means fully satisfied gases who have the fulfilled outer shells. As you can read here, which have completely filled valence shell. Valence shell means the most outer shell. Show little chemical activity. We therefore explain the reactivity of element as a tendency to attain a completely filled valence shell. Therefore, what we are doing is reactivity means completely fulfillness of the valence shell. Its ability is called reactivity. Suppose one molecule have two extra electrons in the outer shell. So what that will do for the complete tendency of being valence, he will lose the two electrons from the outer shell. That's why its reactivity is 2 plus 2. We know it already from the standard 9. Let's have a look at the electronic configuration of noble gas and some metal and non-metals. We can see from table number 3.3 that sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell, and that has the stable octet. What is the meaning of this line is sodium have the electronic configuration 2 8 1. 2 plus 8 plus 1 will gives you 11, and 11 is the atomic number of sodium, atomic number of capital Na. Sign of the sodium is Na. If the most outer shell will remove the one electron, then most outer is the M shell, then L will become the most outer cell and it will have 8. That's why here is word octet. Somehow this reaction all elements doing and become stable. The nucleus of this atom still has 11 protons. In the nucleus there will be 11 protons because there will be no changes in the structure of neutron. Atom just can donate or accept the electrons. Protons will remain as it is, but the number of electron has become 10. So there is a net positive charge giving us a sodium cation. Cation means positive charge. Why? Because it have one proton in the plus number than the electron, where 11 protons and 11 electrons in the atom at earlier stage. In that state the sodium ion was in balance, but after the valency what will happen, 11 protons will be there, but uh, electron will be 10 only. That's why one proton will be in the plus manner, and 4 proton we are putting here plus sign. On the other hand, chlorine has 17 electrons in its outermost shell, and it requires one mole electron to complete its octet. So what chlorine will do? It will accept one electron, and in the center of chlorine there will be 17 protons, and after valency chlorine will have 18 electron, means one minus charge in the extra. That's why we can write Cl minus or Cl minus 1. If sodium and chlorine were to react, the electron lost by sodium, whatever the electron will lost by sodium, could be taken up by chlorine. After gaining an electron, a chlorine atom gets units negative charges because its nucleus has 7 protons and there are 18 electrons. Means 1 minus charge will be plus here. In its K, L and M shells, this gives us a chloride ion Cl minus. So why Cl minus? Because chlorine is accepting one electron from the other. So both these elements can have give and take relation between them as follows. How they are give and accept? Sodium will have 11 electrons as like 2, 8 and 1. When sodium will lose this 1 electron, it will become 2 and 8. This electron will be removed from sodium. Cl who have 2 and 8 electron and outermost shell have 7 electron. It needs 1 electron loosened by the sodium. So this electron will attach here and the final structure of sodium will be 2, 8, 8. So in this case 2 and 8 sodium is also satisfied and this L minus 288 will also satisfy. But because sodium loses one electron, it is the sodium cation. Cation means cation means plus, and because chlorine accepts one electron, that's why it is anion means minus. And if you can want to write both the reaction together, then sodium plus Cl. Here this dot is stands for one extra electron of sodium and this cross is stand for 7 electrons of the chlorine. This 1 electron will go to the chlorine. That's why your reaction will be sodium plus and Cl minus like this. It is the formation of sodium chloride. Sodium and chloride ions being oppositely charged, attract each other and are held by strong electrostatic force. These both will bind with each other with which type of force? Electrostatic force. Underline this word. Of attraction to exist is sodium chloride and our final product will be NaCl sodium chloride. It is a common salt. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions. Let's see the formation of one more ionic compound, magnesium chloride. How magnesium chloride will be formed? See here, magnesium will have 2 extra electron, so it will donate 2 electron, but chlorine will need just 1 electrons only. So what will happen? To donate 2 electrons, magnesium needs 2 chlorine. It means magnesium have this 2 extra electron. It will donate 1 electron to one atom of chlorine and another electron to another atom of chlorine. That's why your product will be magnesium 1 atom but chlorine 2 atoms. So Mg and Cl 2. Here you have to write 2. It means 2 atoms of chlorine and 1 atoms of the magnesium. Why 1 atom? Because magnesium have ability to donate 2 electrons. The compounds formed in this manner by the transfer of electrons from metal to non-metal are known as ionic compound or electrovalent compound. These compounds are known as electrovalent compound or ionic compound. Can you name the cation and anion present in MgCl2? Mg will have 2 cation and Cl2 have 1 anion. Cl minus and this one is Mg plus 2. 3.3.1 Properties of ionic compounds we will see in the next session.